Hello viewers, in this video I'm going to take you through a brief introduction to chemical equilibrium. Now, what is chemical equilibrium? In order for us to understand what chemical equilibrium is, we need to first understand the two types of chemical reactions we have, which are the reversible and non-reversible chemical reactions. So we have reversible and non-reversible. So we have those two types of chemical reactions. So what are these two types of chemical reactions? When we talk about a reversible type of chemical reaction, we're talking about a chemical reaction in which reactants can change into products and products can also change back into reactants. If we have such type of chemical reaction, it means we have a reversible chemical reaction. Reactants turn into products and products can turn back into reactants. That's a reversible chemical reaction. What about a non-reversible? For a non-reversible chemical reaction, you'll find that reactants can change into products, but products cannot change back into reactants. So if you have such type of chemical reaction, it means that's a non-reversible chemical reaction where reactants turn into products, but products cannot turn back into reactants. The reversible chemical reactions are represented by these arrows, or rather, they can also be represented by two arrows, two arrows, depending on the type of book we are using. But if you see this type of chemical reaction here, represented by these two half arrows, it means it's a reversible. Even this one will still represent a reversible chemical reaction. If you have a non-reversible, it's just represented by a single arrow, meaning we're just going one way, we can't come back. This represents, say, you can go and you can also come back, you can go, you can come back. It's a reversible type chemical reaction. So those are the two types of chemical reactions. We have the reversible, those that can be reversed, and non-reversible, those that cannot be reversed. Yes. So now, in these reversible chemical reactions, if they keep on going on, you find that you reach a state in this chemical reaction, which is a reversible chemical reaction, where the rate of the forward reaction is equal to the rate of the reverse reaction. The rate in which reactants are changing into products is the same as the rate at which products are changing back into reactants. When you reach such kind of state in this chemical reaction, it means we have reached what we call chemical equilibrium. Because the rate at which the reactants are changing into products is equal to the rate at which the products are changing back into reactants, you find that the concentrations of the reactants will remain constant, as well as the concentration of the products will remain constant. So let's first write the definition for chemical equilibrium. So we'll say it is a state in a chemical reaction where the rate of the forward reaction is equal to the rate of the reverse reaction. We'll continue to say and the concentrations of both reactants, reactants and products remain the same, or we'll say remain constant. So that's what we have. If we have a state in a chemical reaction where the rate of the forward reaction is equal to the rate of the reverse reaction and the concentrations of both the reactants and the products remain constant, it implies to say what we have is a chemical equilibrium. Now let's understand this. When we say the concentrations of the reactants and products remain the same or remain constant, we're not saying they should be equal. What is equal is just the rate of the forward reaction and the rate of the reverse reaction. This is what is happening. For example, if we have, let's take an example of 3 balls. We have 3 balls on the left side and we have 2 balls on the right side. Let's say this is the concentration and that's the concentration on the product side, on the reactant side. If the rate of the forward reaction is equal to the rate of the reverse reaction, it means if we get one ball from here, take on the other side, and at the same time we get another ball here, bring it this side. You find that we have gotten something from here to give you on the other side, and we've gotten something from there to give on this side. It means this number of balls we have here, the number of balls we have on the left side will remain the same, as well the number of balls we have on the right side will remain the same, because when we get, we also give. Okay, we get and give, meaning it's more like an exchange. You give, you get. So the number of balls you have here will remain the same, and the number of balls you have on the other side will also be the same. So this is the concentration we're talking about, and the rate we're talking about is the amount of giving. What we are giving is what we are receiving. So we shouldn't mistaken this last statement to say the concentrations remain the same or they remain constant to be equal. No, we're not saying the concentrations will be equal, but they'll remain constant, meaning they're not going to change. Now, from there, hope we now understand the definition of chemical equilibrium. From there, in this definition, we have introduced 2 terms, the forward reaction and the reverse reaction. What are these 2? When we talk about the forward reaction, we are basically talking about the changing of reactants into products. When reactants are changing into products, that's the forward reaction. And for the reverse reaction, when the products are changing back into reactants, that's what we call the reverse reaction. So if you want to define them, say the forward reaction is a reaction where the reactants are changing into products, and the reverse reaction is where the products are changing back to reactants in that way. So that's about the forward and the reverse reaction. Now from there, I want to show you 2 types of chemical equilibrium. But before we do that, let me give you this example. For example, if we have a chemical reaction, let's say this is A added to B, okay, giving us C and D on the other side, giving us C and D on the other side, you find that if the rate at which these are converted to that is equal to the rate at which these are being converted back to this, it means we have a state of chemical equilibrium. So let's now look at the 2 forms of chemical equilibrium. Two forms of chemical equilibrium. What are these forms? Now, what we are saying here is we have 2 forms. The first form we have is homogeneous type of chemical equilibrium, and the other one is heterogeneous type of chemical equilibrium. What are these? By now, you should understand, say, when we say homo, we mean one. And when we say hetero, we mean more than one. Homo means one, and hetero means more than one or many. So when you talk about the type of chemical equilibrium known as homogeneous chemical equilibrium, for example, if we have this chemical reaction here, A added to B, giving us C and D on the other side, if the states, remember we learned about states of matter. So these states of matter can be solid, liquid, gas. We also have another state of matter, which is aqueous. Now, if we have all the species, all the chemical species found in a chemical reaction to be in the same phase, okay? If this chemical reaction at equilibrium is having all its species in the same phase. For example, here we have gas, this is in gaseous form, this is in gaseous form, this is in gaseous form, this is in gaseous form. It means we only have one type of phase, which is gaseous phase. This implies to say the type of chemical equilibrium we have here is the homogeneous type of chemical equilibrium. So the homogeneous type of chemical equilibrium is chemical equilibrium where all the chemical species are in the same phase or the same state of matter. All the chemical species involved in a chemical reaction are in the same phase. That's the homogeneous type of chemical equilibrium. So even if this was in aqueous and this also in aqueous, this also in aqueous and this also in the aqueous state, it will still be homogeneous type of chemical equilibrium as long as all the species that are there are basically in the same state. It means you have a homogeneous type of chemical equilibrium. The other one, which is heterogeneous, it implies to say you have more than one phase or more than one state of matter in this chemical reaction. If we only change one of them, you can have gas, 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 but if this is not in gaseous state, it means that's no longer homogeneous, but it's heterogeneous. So for example, if this is not in gaseous state, but we put it in aqueous state, it means now we have three in gaseous, but one is in aqueous state. That's no longer homogeneous, but heterogeneous. We can have them different, like maybe two are the same, two are different, or maybe, yeah, in each way, as long as they are not all the same in the state of matter or in the phase, it means what we have is a heterogeneous type of chemical equilibrium. But if they are all the same, it means we have a homogeneous type of chemical equilibrium. So those are the two types or two forms of chemical equilibrium that we should know. So in this video, we have talked about reversible and non-reversible chemical reactions. We've talked about the forward and the reverse chemical reaction. We've defined also what chemical equilibrium is. We've looked at two forms of chemical equilibrium. I hope you understood that. So if you found this video helpful, please subscribe to our channel, like, comment, and turn on the bell so that you can get informed whenever we post a new video.